H1 is obtained using uh, the wet bulb temperature, the vapor pressure of the wet bulb temperature, which is 6.6328 kilopascal. Then using the humidity formula, which is PA over PT minus PA times 18 over 29. So from here, we can use the vapor pressure of the wet bulb temperature, which is 38 degrees Celsius. So, the pressure at 38 degrees Celsius is 6.6328. So we can get H1 from there. So we have H1 is equal to 0.0435. Then next one is we can get H2. We can get H2 here using the 2.5% humidity given. Then let us equate it to H2 over the H saturation times 100. So we have the 2.5% humidity here. Then we can get the vapor pressure of the saturation, which is 90. So it is 0.070182 over the total pressure minus the given vapor pressure times 100 times 18 over 29 times 100. So we can get here, we can get here H2. So we have H2 here, which happens to be 0.03497. Now we can get VH1 since we have H1 here. So we can substitute H1 there. So we can get VH1, which is the humid volume. So using the formula RT1 over P times 1 over 29 plus H1 over 18. So R is 0.08206 times 40, which is the temperature, which is the temperature of air which exceeds the dryer, times the next factor, which is 1 over 29 plus H1 over 18. H1 is 0.0435, as I said. So we can get VH1, which is we have to use VH1, and this temperature would be Kelvin. So we can get VH1 as 0.9478. Next is for the VH2, noting temperature will be Kelvin, my bad here. So we can, using H2 here, we can get H2, which is 1.0850. Next, using the water balance, we have H1, H2. We have to find F and W1 and W2. So here we have F, which is obtained using F is equal to F times 1 minus 0.15. 0.15 is the initial moisture. So we have to make it dry basis. So we got 510 kilogram per hour. Next, we have to find W1 and W2. We just have to convert the wet basis moisture to dry basis moisture. So at 15% moisture, we can get W1 by using 15 over 100 minus 15. We can get 0.1765 here. And W2, which is 2% moisture on dry basis, now it is 0.0204. Now we can isolate W here, so we can get W. So it is, what we got is 9333.06. Now we can get the volumetric flow rates of air entering and leaving by multiplying VH that we got, which is the humid volume, and the W that we got. So computing Q1 is 933.06 times the VH1, which is 9478, and dividing it by 60 to make it cubic meter over seconds. No, minute. My bad. So the answer is 147.43. Next would be Q2. Again, multiplying W and VH is 933.06 times 1.0850. So dividing it again by 60, we can get 168.77 cubic meters per minute. So we have to box this out. There. So next, what is required is volumetric rate of the fresh and recycled air streams. Now, we have the formula for the volumetric flow rate of the air stream, fresh air stream. Let's note this as fresh air stream. Next, it would be QR, which is the recycled stream. Next, we have to set two equations. First is the material balance of the fresh air stream and the recycled stream, and the solute balance of the fresh air and the recycled stream. So we have equations 1 and 2 here. So I have set it up already. So 933.06 is the total W, is equal to WA plus WR. Next would be 2, which is 933.06 times the 0.03497, which is the HI prime, is equal to WAHA plus WRHR. So we have 0.03497 here. So we can compute by using, we have to find HA. HA is then, we have to use the dew point temperature, which is 10 degrees Celsius, of the dew point. So the vapor pressure there is 0.00122282 times 1000 to make it kilopascal over 101.325 kilopascal minus the kilopascal of here, which is then converted here, times 18 over 29. We can get HA, which is 0.00762. Next would be WR. HR is equal to H1, since it is the recycle here, which is the same property, here. So we can assume that HR is equal to H1. So solving simultaneously, we can get WA and WR, which is 2218.81 and 7114.25. Next, we have WA, and we have to have VHA and QRWR VHR. VHR is equal to VH1, as I said, since same property as 0.1. VHA, on the other hand, we have to use the temperature given, which is 28 degrees Celsius. Then using this formula, then 28 degrees Celsius, we can get these values. So dividing it by 60 again, we can get 31.88 and 112.38 cubic meter per minute respectively. QA and QR. Okay, so next letter would be C, which is the heat supplied to the preheater. Now we have this formula for the total heat by the preheater, heat supplied by the preheater, which is QH equals WI2 minus WIA plus WRIR. Since we have WA and WR that we obtained on the previous letters, we have to find I2, IA, and IR, which are the enthalpies or the humid enthalpy. Using the equation 1.005T plus H times 1.884T plus 2501. So using this equation, we can get the humid enthalpies of the respective masses. So now we have to get them. To get IR, we substituted the temperature at the recycle stream. No, I mean the exit stream on the dryer, exit air stream, which is 40. Then substituting the H that we have there and 40, we can get IR. Next would be IA. At the same time, IA, which is the fresh air entering, we can use the temperature which is 28, and I2, we can get the humid enthalpy of I2 using the temperature 90, which is the hot air temperature exiting the heater, which exits the heater. Okay, so now substituting everything, we have 933.06 18384 221 time minus 2218.81 times 47.5995 plus 7114.25 times 152.27. We can get QH, which is 2693462.351 joule per hour. So we have to convert this to kilowatts, which is 0.7482. We have to divide this by 3600 seconds, and this is 1 hour. So we can get 7482 kilowatts. Next would be the heat loss by dryer to the surrounding. Here, heat loss by dryer to the surrounding. Heat loss by dryer to the surrounding, we have this, we don't have this yet, and we don't have this yet, so we have to compute for that. So computing for the area is pi times the diameter and the wall thickness is added times the length. So it is pi LD actually. So computing for this, no, we don't have to compute it. We can hang that up. So getting delta log mean using the temperature, hot air temperature, which is 90 minus 28, which is the fresh air temperature, minus 40, which exceeds the dryer, minus the fresh air temperature again, over ln 90 minus 28 over 40 minus 28. So computing for that, we can get QL, which is 157,823.05, or converting it to kilowatts, which happens to be 157.823. Next, for the external heat requirement to the dryer. So it is the summation of Wi1 minus I2 plus FH2 minus H1 and QL. So we have to compute HS. We have to compute HS by using CPS plus 4.184 W2 TS2 formula. So we have 4.4 given, direct substitution, and 0.024 that we got a while ago, and using the temperature at the exit feed, which is 33 degrees Celsius, we can compute HS2 and we get 148.02. Next would be for the feed stream, 4.4 again, which is the specific heat of dry solids, plus 4.184 times 0.1765, which is W1 times TS1, which is 28 degrees Celsius. So computing for that would be 143.88. So we have to compute QD. No, don't mind this first. So QD is equal to Wi1 minus I2 plus FH2 minus H1 plus QL. So we can compute that. We can substitute everything that we got. W is 0933.06. This is I1, which is what? We got this a while ago. I2 as well, which is I2 plus 510 feed. Yes. The feed we got, and H2 here is 148, which is this 148. Next 143.88 here, plus QL here is converted to kilowatts right away, so we can get QD by computing everything, 76.56 kilojoules. There you go. We got the external heat requirement to the dryer. So that's all for the OSR video, and God bless. Thank you.